Hello, Mario! Welcome back to Maurieos cul-de-sac 8, vertical alignment 2. Just to recap where we left off from vertical alignment 1, I had made a copy of our original horizontal alignment with a number of the layers turned off and only the relevant ones showing, and so then we zoomed in to there and we looked very carefully at getting all of the distances, this particular to where the contours intersected the horizontal alignment. These were all recorded on a spreadsheet, an Excel spreadsheet, and we've now have the various along here, various chainages at each chainage and where the contour interval is. This will enable us to create a long section. And so I've started work on the long section here, and I'm wanting to have my long section at approximately a scale of 1 to 500, which should fit in the page reasonably well. So let's just put that in there, lock and load, and let's just go and have a look. So zooming in here, what I've done is I've started along here with a base of 0 there. That's my baseline of 0, and I'm working, as we do in model space, working in one-to-one, so the real life thing. So the first thing I've done is I'll just put that onto single capture. I've just plotted in here this distance 27.033, which you'll recall is the calculated level of where we're going to come off the existing centre line. And then what I've done is just made a copy in here on my typical cross section and put that in there like so. So now it remains to work through and put in the surface. Now, in terms of the area inside the typical cross section, I've given the typical cross section priority. The heights as determined by the typical cross-section take priority over the contours because they are more accurate. So there was a contour, a 27.2 contour right in here just on the boundary, but I've taken the boundary value as given by the typical cross-section. So the first contour we have to plot is this one here, the 27.4, and you can see that I've plotted it there, and I've put it I should have put it in a layer that I've called surface, which will enable me to turn it off later on. And then I've put this one here, of course, should be in a layer called alignment, because this is part of the alignment, this one here. So I've got two layers, so there's the surface ones won't show up in the final thing. This one here, of course, these are part of the alignment. As you can see, you'll see down the bottom there that I've started to label that up. So that's the 18.45 chainage, which is part of the alignment. So when I turn off, as I can do here, if I turn off surface, the layer that I've called surface, if I turn that off, you can see that all of the ones that determine the contours, because they're not particularly relevant, disappear or are turned off, and we've just remained with the alignment one. So I'll turn the surface back on again just to show you a little bit more about how that works. Now what I've done here is obviously with my spreadsheet on my second screen, or cut my screen in half, I've put in here all of the little distances that we measured, and then I've made sure that they key into the various points from the alignment, so making sure that when I get through that they all fit within a millimetre or so. Then once I've got all those distances here, which is this in the magenta line, I've just drawn a vertical line from the from my base, from my 0, the height of the whatever the contour is. So this one here is 27, for instance. If we go to one single capture, this one here should be 27.6. Now, how I do that is I use the len command. So let's just say I just draw in a random line through there, and I use the len command, or length, L-E-N. Okay, I'll put that length in, and then I use the total one, and then I say, well, I want it to be 27.6, and then it asks me, and I just select that there, and it puts it in at 27.6, like that. So I went through and put lines at all of the various intervals through there, and that enabled me to plot up the surface. Now you'll notice on the spreadsheet, of course, I'll just quickly go back to the spreadsheet, I had these red lines. So at 18.45, I've got a red one. Now they're ones that I have actually interpolated from the thing. So what I did there was I just used my extend command. So once I had my surface in, or my original surface, or my ground level, I just used my extend command and just selected that there, and then just extended these values like that, and then obviously I can click on that, and that'll give me its value, 27.410. So I'll just go back to where I was with that, because I have now subsequently trimmed all those back so that they fit the alignment. So there we are. I've got my surface all in there like that, and then I turn off my surface layer, because I don't want all those lines and things on my final long section. So I just go down to my surface layer here. Eventually, surface layer, and I just turn it off, and I'm left with just all my the surface. Obviously I join the tops of the surface to create a surface. I've just used straight lines, but you could make them into a continuous polyline and possibly even spline it and that, but it seems to look pretty good there. So now it comes to actually determining my vertical alignment. Now one of the things that we've got to do is this is the existing road, and it's got a 3% crossfall. So we must continue that 3% crossfall so that we don't have a big bump at the intersection that we just drive down. Now that slopes at 3%. And what I have done with that particular slope, if you recall, if we go back, I'll go back to the roading plan perhaps here. If we go back there, we can see that here's our intersection here, and out at 18.45, we've got all the we've got curves and that, and then we get into our typical cross section. So we've got to put some sort of vertical curve in at this point, because obviously we're going to have the vertical, we're going to come down at that, and then we're going to put in another grade going up the way to the cul-de-sac head. So, and then we've got to gently come through there. So I'm going to be starting my vertical curve at 20 actually. I thought that was a pretty good place to start, and I'm going to have a 40 metre long vertical curve. So I'm going to go from 20, the IP of the grades, my intersecting grades for when I start to go up to the end there is going to be at 40, and my vertical curve will finish at 60. And what I have decided in my wisdom is that I will also be putting in a couple of extra points on the vertical curve at 30 and 50 just to give me some calculation points for the vertical curve. Now with regards to the grade going up, so I'm going to come down at 3% and through to 40 metres, and then I'm going to put my grade up to the top. Now what I did for that grade there is I just chose a point at the top of the cul-de-sac here. I thought I'd want it slightly just below ground. I want my road to be in the ground, because that way the sections will all be up above the ground, and we can use the road itself as a ponding sort of area in times of high intense rainfall or stormwater events. So I just randomly chose a point in through there, and as it turns out, the height that I chose was 30.084, so nothing particular, and then from that I was able to, I can determine that obviously that the length there, well obviously I can work out the length because I know I've got 114.366 or something like that, and I've got the delta y, which is 4.251, but we can work out a gradient for that point. Now at the end of the cul-de-sac, we've got to be a bit careful here. At the end of the cul-de-sac, if we have a 3% grade coming down in here for 10 metres, and we've also got a 3% grade going across the right angles, obviously this point here is going to be at the same level as the points either side of the centre. So I tend to raise that up, and I've put that just at this point in time, I've just shown that there, it's 10 metres obviously from the centre of the, I've just put a 1% grade across there, and then put in my typical cross section, just from the curb to the boundary, that would stay the same, that would go in there. And I'm hoping that by just keeping that at 1%, that we'll be able to grade around, we'll have 200, probably obviously 10% out that way at 3% will give us 0.3, this will give us a 0.1, so we're going to have 200 mils of fall hopefully around the cul-de-sac, so that the water will drain out of the cul-de-sac, and that will reduce our stormwater pipe lengths, because we can put our catch pits significantly outside of the cul-de-sac. We don't have to bring our stormwater reticulation quite as far. That's further down the track. And then I've also come through to the boundary, and then I've shown here, this is my cut or fill back to meet into the existing surface, and I've got that at 1 in 10, or a 10% grade, which is sufficient for just not too steep, but not too flat, and that's where things will cut back into the existing thing. So that enables me to draw all that in, and then I have put in my the key points on the alignment, and then I've trimmed them to my design. But what remains to be done here is to put in my vertical curve. And the vertical curve, and I check these against these values that I'm getting here, I check those against my spreadsheet. So if we go to the spreadsheet, you can see here on the spreadsheet that these are the values the surface values that I've interpreted for each of these points that don't, that's where they intersect the surface. And then if we just pop up here, we're going to look at some of the design, what the design values were, and I haven't put them into my long section yet, and that will be the subject of my next video. Obviously I'm going on a bit here. So this is here's our grade. We had the -3%, and then I calculated a 3.7170% up to the centre of the cul-de-sac, and then I've just left that open there for now. So you can choose, you could have many different scenarios. You could choose to have your cul-de-sac and fill or whatever. So you must, this value here won't be set. You need to determine that, and that's been determined by my 30. I think I've done a calculation in the thing there, and that's possibly, if we look at that, yes, clicking on there, that's 30.804 minus 25. That's giving me my rise, and then the 12. The 40, from 40 to 154 is giving me the run, and from that we've determined the gradient in there, and that's all been worked out. So from those gradients we can work out through to here, which is, as it turns out, will be the IP grades. Okay, and this will be, here is where the vertical curve starts, so that'll be a tangent point for the vertical curve, TP vert in there, and this will be the other TP vert here at 60. Okay, so now it remains to calculate, obviously, for the vertical curve, we need to calculate the corrections to allow to come from the grades to create the curve. And I've put in this little formula here, or this copy of the formula here from my video, Maureo calcs a vertical curve, and we can see that what I've done here is I've calculated the distance, or the y, which is the distance along the curve, which is pretty straightforward, given that we're starting at 20 to 30, so that's them there. This is M, this is the grade, obviously that's the 3% here. A is the algebraic sum of the grades, which is, if you look here, that's just the one minus the other, gives you the algebraic sum of the grades. 40 here is the curve length. I haven't actually used that. And then this first bit here is calculating my. Just remember that these are shown as percentages, but they're not actually divided by the 100. So all you need to do here is just multiply them out. So that's looking good. And then this is the second part of the calculation, the AY squared over 200L that I've done there. Again, these values here are already divided by 100, so that becomes 2L rather than 200L, and that becomes 1. I've put those in there, and that gives me the total correction, which I've put back into the spreadsheet over here. Now, then this gets added to the 26, which is the RL of the first tangent point. So that's getting added to that to give that. As you can see, they all refer back to that first one here, and then this one here. Looking at this one here, that plus that agrees with what we've got there. So that's all very good. Yeah. And there we have it. So that's got all that calculated, and so it remains now to come back to my long section here, which in the next video I will be showing you how I've got the curve in, and we've got the the long section pretty much finished. So one more video on the vertical alignment and we'll be done there.